Hi everyone, welcome to the channel. Today I'm excited to share with you a new web-based parametric modeling software called Beegraphy. So I've been following the development of this software for a while now, and it's come a long way, and I'm excited to do a demo for you today where we will look at some of the functionalities of the interface and what you can actually do with it. So the product is not yet perfect, but it's still under development. So I wanted to basically introduce this software for you so that you can actually create an account, play with the interface, and give feedback for the developers. So we're going to look at the beta version today, but it's still under development. And if you can interact with the software and send us some feedback, it will be great. I want to first mention a few things that are great about Beegraphy. It's basically web-based. It's free to use. It's great for designing products, also producing collaborative teams where you can work on similar models online. You can produce models that you can 3D print or use other means of fabrication. You can also do web-based parametric modeling. So this is basically a great platform for computational designers to come together and collaborate on projects. So I think also this will have some educational avenues for exploration where you can also look at people's code and give feedback on how to improve them. So today we'll be looking at a parametric model and producing it in a way that we will be able to share it with a link, and using this link we'll be able to customize the topology or the form of the model. I would basically introduce you to the editor platform, but you can basically go ahead and create your own accounts and start playing around with the software. So without further ado, let's keep logging in and seeing how we can work with this environment. So I'm going to go to login here. I'm going to log in using my Google account, and you can basically enter your full name and create basically a handle here. So I'm going to write Parametric. I'm going to choose search on the internet, choose any type of profile, image. You can upload an image of your choice and go next. Now I'm logged in, so I can go to the editor, and now I'm in the editor platform. So here you can create a new team if you want to develop a collaborative project. You can publish some works here. I don't have any models at the moment, but the tabs on the left basically show us the kind of inventory we have. And let's actually jump right into the interface here. So go to the new model, and I'm going to create a parametric vase today. So let's call it parametric vase. Hit save. So we're going to it's going to basically load the parametric modeling interface, and we're going to start working with some plugins. So the interface is actually similar to Grasshopper, which is basically great for computational designers, because I think most of you that watch this channel, you're using Rhino, Grasshopper tools, but the interface is kind of similar, so that you will be able to actually use similar tools. All right, so here we have our web-based canvas, and I'm actually going to drag this to the left because you'll be seeing my camera on the right. So this is basically our modeling environment. So whatever parametric model you do, you'll be actually seeing it here, and it basically navigates the same way with any type of modeling platform. So you can zoom in, zoom out with the roller. With the left mouse button, it does rotation, and with the right mouse, it does panning. So I'm actually going to start with a 2D exercise first. So I'm going to look at it from the top view, and we're going to zoom into the origin, and I'm going to create basically a circle, a parametric circle, but then we're actually going to play with the kind of curvature of the circle. So we're going to create kind of an undulating profile that we can use. So let's actually start with the circle equation. So I'm going to call in some functions. So let's say we start with a number value. So let's call 360 degrees as a number constant. So this is basically the circle going to be the degrees that we're going to use. And then I'm going to divide it into a bunch of points. So let's say we have 30 points. You can also do range input. Now range input is customizable, so you can actually define minimum, maximum values and also the step. So I'm going to keep it at 30, and I'm going to divide these two numbers. So let's divide 360 by 30. So we're going to have basically, in order to see the output, you can create a panel here. So let's see what we get. We got 12. So I'm basically calling functions directly on the canvas by double clicking on it, but you can actually look at these drop downs on top where you can find a bunch of plugins as well. So for instance, if you want to create, let's say, an input, basically a number slider is here, range input, so you can click and drag it here, and this will be your range input. Let's call this like a parameter that we want. So I already had one here, but let's call this number of points, so you can rename it. The cool thing about these tools is that later on we will be developing some of them to be parameters of our web-based model, and when we share them, if you rename them as a specific parameter, then you'll be able to basically customize them on the web. So this kind of compresses the whole code into a bunch of parameters that you can actually play around with. So I'm going to now create basically the circle, the points of the circle. So in order to do it, we need to call in sine and cosine functions. So they will be located under Math tab here under sine and cosine. So I'm going to drag them here. So by default, these take in radians, but there's a way we can change degrees to radians. I'm basically going with a degree calculation here to draw a parametric circle. So we have 360 degrees divided by 30 degrees, which gives us 12 points total. And I'm going to use basically this value here to find the points around the circle. So let's go to list and sequence. This is kind of similar to series component in Grasshopper. So I'm going to start with 0. The count will be basically 30, and my step size will be 12. So this will now create 30 values, and these all have the angles that I need for the circle point calculation. So these are basically degrees. So 0 degrees to 348 degrees. So they're going to get intervals of 12. So I'm going to transform these into radians. So you can use degree to radians component. So once we change that, now we have their radian version. So if you plug this in, you can see they're written in the version of pi. Now I'm going to combine them into cosine and sine, and if I just click here and type in XYZ construct point, now this cosine will be my X and this will be my Y, and we have basically our parametric circle now. So these are all the points, and let's actually start playing around with this. So let's say that we want more points, so I need 60. If you enter 60 now, you get more points. Sometimes it takes a while to refresh the screen. Basically, we need to, let's see, let me turn this down, zoom in a bit more. Let's see where we are. We are here. Okay, there you go. So we have 60 points. Let's say we need less, so I'm going to divide it to 12. So it's kind of reacting. It's a bit more responsive now in the top view. So these are basically the points around the circle. What I want to do next is actually embed some multiplication. So what I want to do is create some sort of an undulation for these points. But let's actually close the circle first. So I'm going to do an interpolate. We can actually do interpolate, or you can do curve. Let's look at the curve function. There should be a bunch of curve tools. There might be also NURBS. Let's call it NURBS. NURBS curve. Well, maybe it's under tool. We have a bunch of tools here. So let's go to primitive, and I think NURBS curve is here. Interpolate is also here. There's also polyline. So I'm going to start with the NURBS curve, and what I want to do is these are the points. You can see it's not closed. In order to close it, we need to attach a boolean. You can either type in a value, or you can just add a switch here. So we want it to be closed. And the degree could be just number 3. So 30 would be a number constant. So we can make a third degree NURBS curve. So this is basically the starting point of the sketch. The next phase would be to actually push and pull these points in a way that we create some sort of an undulation. So to do that, I'm actually going to use another function called remap. So what I want to do next is I want to actually change the multiplication for the XYZ components. So these are actually giving me points around the circle, but what if we want some sort of a sinusoidal mapping? So what that means is basically, what if some points are outside and what if some points are inside, right? So we want to create some sort of undulation around the periphery. So one way of doing it could be achieved by basically multiplying the degrees with the sine function. So it might seem a bit technical, but let's actually do one, and then we will do a bunch more. So I'm going to create another sine here. So what I want to do is basically, since sine function actually creates a single undulation in 360 degrees or 2 pi, I want to create or control how many undulations we want. So let's say we want to create 5 undulations. So I'm going to create this as a range input, and I want to start with, let's say, 2 to 10 and the step to be 1. So I'm going to call this as lobes or undulation. So we're going to create a segmented form, so that's why I'm calling it this way. And then I'm going to multiply the radians with this value, and this would actually give me basically higher values, higher radian values that could be used with the sine function. So now let's look at the output of the sine. So we should be seeing some sort of movement from -1 to +1, right? So that's how sine works. But by multiplying it with 5, I'm actually doing 5 undulations. So this would create, I think for 12 points, we don't get as many. But if I increase the point count, let's make it 30. Now here you would see that if the values start from 0, and then it goes in the positive direction, then in the negative direction, then positive again, negative again, positive again, negative again. And this is basically repeating 5 times, right? So this creates how many times we want the positive negative cycle in the sine. So we can actually use this to remap these parameters. So let's call remap. Now this is similar to Grasshopper again. Now we want to remap these values that belong to a source domain that we already know, which is basically between -1 and +1. So I can create another number slider here. So we can copy paste this. Let's try entering -1. It actually could be minimum is -1, positive is 1. So this will go into -1, and our source domain is between -1 and +1. But what we want to do is make this into kind of a radius value that is increased. Right now you're looking at a circle that has a unit radius of 1 to find the position of these points. But what I want to do is basically increase the radiuses, radii, so that some of them are further away, some of them are closer to the origin. So we just need to basically enter two values here, two more number sliders. So one of them could be, let's say 3, and the other one could be 6. So I'm going to start with 3, and I want the maximum radius value to be 6. So these are basically the new radius values for my points. So we can actually multiply them with cosine and sine and see what comes out of it. So I'm going to do multiplication here, and this number will be kind of a coefficient that multiplies with cosine and sine. So I'm going to move this around a bit more. Let's move it here. So this goes here, this goes here. So what this will do is it will basically create the undulation of points by manipulating the radius value. So if I look at the panel, you can see that we have basically 12 values here, but let's actually see, we still have 12 points. Let's increase the values. Let's have 30 points. So for 30 points, we're actually calculating the radii. So if the points are pushed outward, they get closer to 6, which is our target max. If they're pushed inward, they get closer to our target min. And it's basically mapping the negative and plus values to these in-between values, right? So we get values between 3 and 6. So this will be our y value, and this will be our x value. Now let's see what we get. This one also connected. Let's actually delete this, make another construct point. This is x and this is y. All right, there we go. So now these will be my points. Let's actually do another NURBS curve. Sometimes the screens do not refresh in time, but you can see here we've created a star, a 5-lobed star. So the reason why I wanted to do the lobes here is because I'm multiplying the total angle, which is 360 degrees 5 times, right? So I want to make 5 cycles of sinusoidal mapping around the circle. So this will now create the lobes. So if I basically make it 4, now we have 4 lobes. If I make it 3 lobes. So if I increase 6 lobes, 7 lobes, so now we have basically parametric profile that we can use. So I'm going to keep it at 5 and see what we can add up to this actually. And keep in mind, all of these parameters are kind of connected, right? So if I basically increase the number of points, that's going to improve the resolution of this profile. It seems to be fine at 30, so I'm going to keep it at 30 for now. Now, the next step is to work in 3D, and basically we want to make a series of these operations, right? So I want to make copies of these profiles so that we can create maybe some sort of a loft. So I'm going to start by actually making points where these this profile could be translated to. So let's actually start with using something a bit different. So I'm going to use growth sequence, which is another tool, growth step sequence. So it basically starts with a base value and then it increments new values on top of it so that we can use this to kind of stack up a bunch of points in the z direction. So let's start at, for instance, 0. So I'm going to start at 0. Let's say our count is going to be 10. We need 10 profiles. And we can enter 2 more values here. So let's do range inputs. And we can make this anything we want. So let's make them go from 0.1 to 4. And step is 0.1, which is fine. So I'm going to make 2 of these. And let's look at the output. So we want to increment it by some value. So let's go with 1. So this already creates a default series, but this second parameter basically kind of increments the growth, right? So at each step, we are actually growing the interval by 0.6 amount. So that's kind of creating some stacking values that are closer to each other at the beginning, but more further apart towards the end. So I'm going to use this to construct points. These will be the z coordinates of the points. So you can see now this is my sequence, and I want to basically change this to be the location of these profiles, right? So let's start with there. So I'm actually going to let's see what we can do. I'm actually going to move these curves into these locations. So how can we move them? We can probably move them using vectors as well. So what if this is kind of a z component of vector as well? So I'm going to do vector xyz or vector z. So this will be my factor. So let's look at our output. So this will basically be some vertical displacement. So if I do move, I want to move these curves using these vectors. So now we have copies of our profiles basically, right? So they we generated one profile, and now we're actually vertically copying them. So the next step is we can actually try modeling the surface first. So let's loft this surface. And you can see it's basically at the moment a simple extrusion. But in the next step, I'm going to basically make this kind of a twisting shape. So we can actually do it in more complex ways. So I'm going to delete this for now. So let's look at how we can actually do some rotation. So first we moved them each, and I want to rotate each of these geometries now. So how can we do rotation? So there's a command called rotate. So we can do rotate object. I couldn't get it from there. Let's see if we can find it here. So tool, and let's see, transform. Under transform there should be rotate. So we can rotate these geometries. We need to supply an angle, and by default the angle is in radians. So we can actually put again a degree to rad component there. And let's start with another range input. Let's make it 0 to 60. Step size is 1. Actually, let's make step size 5. So let's increase the increments a bit. So this is going to be my angle. The center is going to be the these points actually, right? So how many geometries we have. So let's find those values. We have 10 points and we have 10 geometries. So if I put these points in, they could be my centers of rotation. So if I rotate this, now the geometries are rotating too. So it's kind of visualizing a bunch of things at the same time. So it's showing us this moved profiles as well. So we can actually hide it by right-clicking onto it. We can also hide the base curve here. And we can only look at the rotation. So these are now, the profiles are rotating. I'm also seeing the parametric points at the base. I'm going to basically hide these as well. There we go. So this is a shape that we can rotate. But what I want to do is do an individual rotation per profile. So we want to start with no rotation at the base, and we want to create kind of a twist. So this will be kind of a sequence of rotation. So I'm going to basically do another list sequence here. And we want to start at 0, and I want this to be a degree of rotation. So let's call this rotation. Now we can either make this as total rotation, or we can make it into a single rotation. So it's totally up to you. I'm actually going to make it into a total rotation, so we can make this 180 degrees. And let's say we want to get to 60-degree rotation in some steps, right? So how many steps do we need? Well, this is, we need to define the step size. So here we have 10 values. So let's find how many vertical profiles we have. That number is here. So we have the count. So if I do division again, I want to divide 60 into 10 steps. So these will be my steps, and my count will be 10 again, right? So I'm making these sorts of connections, and let's look at our output. So we have 10 values that start from 0 and go to 54. So we can basically, it's not all the way up to 60, but it's coming close to 60. Right, so we get 54, so one less. Let's try actually with playing with this first. So I'm going to attach this, decrease. Now there we go, we have some sort of rotation, and if I increase this, you can see that the whole form is kind of twisting. Right, so if I do 140, the total rotation will be 126 because we have 10 profiles. But it's kind of looking nice already, right? So we have some sort of twisting shapes. Now let's look at the form. Let's look at Loft Surface. Well, there you go. So it's kind of lofting it very well. And I'm going to delete this again. Let's actually add some more functionality to this. What if we have some sort of control over the sizes of the profile? So I want it to be kind of a tapering shape that starts larger at the base but kind of tapers towards the top. I have one more gimmick to show you guys what you can do with this. So there's something called Graph Editor. Let's see, under input, there's something called Curve Editor. So it's similar to Graph Mapper, but there's something different about this, which is it basically allows you to model a curve, and you can actually use the points of this curve as kind of a driver for certain parameters, right? So we have a 4-point control curve. I can change its degree to be 3rd degree, for instance. Now we can use this to map how much we want to transform each section of the curve. Now we of course need to play around with this a bit and see how we can transform the curve. So first thing is we need to divide these points. So let's say we divide the curve into by count. So I get the curve. So this is already a 2-dimensional curve. So how many points do we need? Well, you can see that the division is already taking shape here. So it's a really large, it has large values, right? So this WH value, that's too much actually. So maybe we can actually make this kind of normalized. So let me actually make it into 1. Well, it kind of clamps at 10, but you can see that curve here at the origin, right? So it's right there. So at the base, so you can see we have 5 points. Let's actually make it 10, 10.0, and these are the points. Well, we can actually make it, this is, I guess, the number of points. Well, I'm not too comfortable with playing with these because I want to manually actually change the shape of this curve. But what I want to do is I want to use something like the graph mapper functionality in Grasshopper. So I want to use the values in one direction to be mapped as scalar values, right? So for instance, if this curve is way up, I want that profile to be large, but if it's way down in y value, then I want the radius value to be really small. So basically we have points here, and we can actually look at the coordinates of these points. So we can deconstruct these points. And let's look at the output of the y value, which is going to be the mapping function. So you can see it by default starts at 9, then goes to 8, 6, 5, and then tapers down. So I want to basically control how these values are mapped, right? So I can do another remap here. So the values I want to map are these y values. The minimum of the source is basically 1, and the maximum is going to be 10. So these are kind of fixed values because I set the curve to go from 10 by 10, so it fits in a grid of 10 by 10. And we can set up a target minimum and target maximum. So let's say our target minimum is going to be 1 again, and this target maximum could be some other coefficient. So we can do a range input here again, and this range input, let's make all the way up to 5, and step size to be 0.5, and minimum to be 1. All right, so there we go. Okay, so what am I going to do with these? Well, I'm going to actually use this to actually scale the profiles, right? So I can basically do some, after I do the rotation, I can actually do some scaling of this profile. So I do scale. These are the geometries I want to scale. And you also want to make sure that the value counts are kind of the same. So let's make sure that this count and the vertical count are giving me the exact same values. So let's look at the output here. So this number, I have 11 values actually. So because we do divide by count, this is taking 1 less value. So I want this to match this growth step sequence parameter here. So the number of sections, we can also make this actually not a number constant, but kind of a range input. So let's actually make it, we want to control maybe the amount of points we have. So I want to start with a minimum of 5, maximum of 15, step size is 1. So let's call this vertical point count. So I want to make it 10. So let's replace this parameter here. And we want to replace this. And one more, we want to replace this division. So I'm going to delete this here. Okay, so this is now controlling how many points we can have. Well, there's a scale. We can hide it for now. Let's look at here, the object. So we should be able to add more points or take out points. So if I make it 8, you can see it's kind of adding more and more points towards the top, right? So this controls the number of points. But now I want to also get kind of the same values by the graph. So if I put in 10, this gives me 11 values. So we want to make kind of a correlation. So I can make a subtraction. If we can subtract 1 from the number of points in the vertical direction. Now this should give me exactly 10 values, right? There we go. So for 10 vertical points, we get 10 scalar values for scaling, and that are kind of read from this graph mapper here, or kind of the curve editor. So I'm going to use the centers where the geometries are located. So those are coming from the growth sequence in the vertical direction. So these will be my centers of scaling, and these will be my factors of scaling. So let's see what we get. So I'm going to show this now, and let's see what we get. And rotation, let's hide it. Let's see. Target max. Oh, the target is 0. So we need to increase this probably. So let's make it into 3. Well, 3 is kind of giving me large values. But let's clean this up a bit. So we have rotation, we have the scale. How many geometries do we have? Let's compare that these are kind of correlated now. So let's look at our panel. We have 15 geometries. Is that correct actually? So we have 10 points coming here. Here we have 15 points. Maybe we need to redo this again. Maybe it didn't clear it from the cache. Sometimes the parameters are not refreshed. So here, for instance, this parameter is, I think, stuck. So here, for instance, we have 15 values, but in fact, I should be getting only 10 values. It's getting kind of the maximum value. Let's actually make it manually enter it. So let's make it 12. All right. So let's see how many geometries we have. We have 17 now. So it kind of keeps adding up actually. Let me delete this and see if we can show here. Well, it still shows 17. Let's actually add one more here, growth sequence. So starting value 0, total value is 5, step size is 1, step size is 2. Okay, so these are my z values. All right, so let's see, we have, well, now we get 22. Why do we have 22? So here, we shouldn't be getting 22. Let's see. Let's look at our vector, because I know we have a single curve here. This is a single curve. This shows 22. Vertical point count. Well, the list should be only 5 actually. I'm only getting 5. Let's look at it again. Panel. Some part of it needs to refresh probably the code. So we only have 5 values here. Yeah, there you go. So let's make this 12. Now we have 12 values. And the vertical displacement though, well, this is getting 29. Well, what about the vector? Let's debug this. Vector is 29 as well. So let's delete this. Vector z. Now this should be, that's 29 again. Well, this is 29 as well. Why is it 29? Let's connect this again. let's try to figure this out. So the geometry, well, it didn't clean it up probably. Here we have, I mean, the move keeps adding on and on. So we have only one curve. So let me actually do this part from the beginning. So let's connect here. So we have 12 values. Let's look at our vectors. We have 12 vectors, perfect. So now I think the problem was with the move function. So it kept adding the vectors on top of each other. Now let's look at our panel. Now there we go. We have 12. And I'm going to place this here. That's our rotation. So these are the moved ones. Now these, we can delete it. Now we have moved. Now let's do the scale. We have 12 values here. So my geometries are here. My centers are here. And my scale factors are here. So let's see. This is actually, this should be correlated. So maybe we should make it short list. There we go. So I guess it was at the longest list. So it was probably mixing the data up. So we should keep it as short list because I'm supplying 12 profile curves, 12 centers, and 12 scale factors. So that should basically do it. Now we have somewhere the moved curves, so I'm going to hide them. And this is, well, it's missing some of the profiles, but let's actually refresh it again. So maybe do it again. Scale. This is the geometry. This is the factor. This is the origin. And we want to make it into the shortest list. Well, it's kind of skipping these profiles for some reason. Why is it skipping those profiles? Well, this is now showing 29 profiles. Why is it showing 29? Let's look at here. This shit says 29 as well. Maybe we have to do move again. I guess there's some sort of history issue with the move. I'm sure they will clean it out. Let's see. Rotate, scale. Well, it's kind of missing those in between profiles. Well, we have 12 here. We have 29 here. So rotate, I have to do rotate again. Rotate object. This is rotate geometry. Angle is here. Center is here. Maybe this needs to be shortest list as well. That's why. So these are now rotated. This is hidden. Well, it doesn't like these profiles here for some reason. Well, the move works. Rotate doesn't work for some reason. Let's see. 29, 12 here, and well, let's do it again. Panel. $12, okay. Another one here, panel. Well, there's only one. How can there be one? Maybe longest list? 29. Why does it say 29? Let's see. How many points do we have? Let's debug this. We have 29 points? Not really. We have only... We have 12 points. Well, why does this say 29? Right, let's delete it. XYZ construct point. This is my Z. This is the center of rotation. These are rotated, and the same thing should be for the scale. Longs list, nope. Well, the rotated ones are there, right? So they are in the right place. Let's hide the moved ones, and let's do scale again. This is the geometry. This is the center, and this is the number. All right, there we go. So I had to do it a bunch of times because let's see, rotate it. Oh boy. What is the issue? Let's find out. So this is 29. This is 12. This is 12. And my radians is, how many do I have? That's 12 as well. That's only 2? How come it's only 2? Well, the count is 12. Step size should be 140 by 12. Oh, that's 1116. Okay, maybe this list sequence didn't work. So start is 0. Step size is this. Count is this. This is my degree. Now this should work. Let's do shortest. Nope. Longest. It's kind of mixing up the values. 29. Why does it have 29? This only has 12. Okay, degree to radians. Probably has to do with the internet cache. Well, how many do we have here? 12. This is 12. And this is 12 as well. But this one doesn't like it for some reason. So let's do rotate again. Geometry, angle, center. All right, and scale. There we go. All right, I was able to do it finally. These, for some reason, they didn't clear up once I disconnected and reconnected because they kind of stuck with, I guess, old values. I guess this is kind of the issue with working on the web. It takes some time to basically clear the history of the script so that you can also have some redo and undo functionality. So they are working on this. I'm sure they will be able to fix it. But basically, we are able to develop kind of a twisting shape with a custom profile now. So I'm going to hide these points. So this all seems fine. Now we have the scale, and I'm going to look at the form now. So let's do Loft Surface. This will go here. And there we go. So we have now a twisting parametric form on the browser. Okay, so we can actually do a lot of interactive modeling with this. So if I basically play around with my curve editor, now I can create some sort of lower scalar value at the base and kind of tapering form like this will control. Let's move this here. Okay, let's see if this is working fine. Maybe I have to reconnect this again. Let's look at the scale again. This one stuck here. So scale, geometry, center is this point, and this is the scale factor, and then Loft Surface. There we go. All right, so let's play around with this. Target max, let's make it 2.5. So it's kind of shrinking the form's base. Perfect. So now we can control the height. Let's see, this one gave me some issues, but I'm going to play around with it to add more points. Perfect. It's kind of working nicely. So we can add more points in the vertical direction. I can reduce the growth sequence. And we basically have it. I mean, we have some parameters that we can use. And now I can actually share this parametric model with a colleague as a link. So, and that's kind of easy to do actually. So we have the loft surface here. So what I can do is apply some material and cap it. So let's do cap here. And we can then basically hide this loft surface and look at the solid shape here. And then I can do apply material. And we can give it any type of color. So let's do color picker. And well, we don't want it to be white, which basically makes it harder to see, but let's give it kind of a nice bluish tone. Makes it stand out. You can also add some metallic parameter or some texture, some opacity if you want. So for instance, let's get the opacity parameter. There's kind of a ratio, so I can basically do range input and make this go from 0 to 1. And we can probably make this transparent as well with this. Let's see if this is working. Well, if it's not working yet, I guess it will work later, but let's take this out. Well, this is kind of cool. So I have a few more things. I'm going to do an OBJ exporter, and that was the whole point of doing this all on the web. And this will actually allow us to develop a parametric model, open it up on the browser, and then be able to share it with others and have them work with it and download it and 3D print it if we want. So that's kind of the advantage of working on a web-based parametric model. So this is, I'm going to stretch this view a bit and see if everything is working fine. So this is controlling number of points, lobes. Let's make it into 4. Well, there we go. So now we have 4 lobes. What if we make it 3? Okay, it's taking some time to update, but it's working really well actually. Okay, perfect. So these renamed the same way, but I'm actually not going to keep these. I guess this was kind of the undulation. So I'm interested in these 2 values, so we can make it surface min, and we can make this as surface max. So every parameter that we're going to use, we can rename them. Every one that we are not going to use, we can actually hide them. So this would actually make them not part of the tool that we're going to share. So number of points could stay. I've hidden these lobes. We need vertical point count. We want these growth sequence parameters. We can actually keep them, but I'm going to hide them for now so that the model becomes a bit more simpler. I want the curve editor. This one is, I think, the scalar value. So we can call this scale up. So how much we want to scale up per section. And then I had a rotation parameter, which is right here. So this is basically total rotation. So I can bring out all of these parameters onto one side, but that's actually not necessary. Let me hide this boolean as well. We need closed profiles. All you have to do is, once we built it and played around with it, you can click on this Beegraphy symbol, and what it does, it basically transforms your model, parametric model, as a web-based interface now. How cool is that? So you can now basically look at the closed shape and play around with it here. So I can basically play around with the point count, increase the rotation if you want to add more twist. Let's actually look at the lobes. Let's increase the lobe count, right? We can add more lobes. Number of points is how many points we wanted on the surface. It's kind of resolution, so let's make it 36. It adds more surface definition. Surface minimum, maximum, I guess these were controlling the undulation, so we can, if I increase this to 4, now we don't have as many creases as we want. Vertical point count, let's actually bump it up a bit. So I'm going to make it taller. And scale up, let's actually make it a bit low. The base goes down. And there's also curve editor here. There we go. So we can actually make this, play around with this interactively, and that will control the profiles, individual profiles. I'm going to increase the base. We can also, if I move these points around, you can see the scale also changes. So since this is kind of a mapped function, I'm getting kind of readings of it in the y direction. So if you're happy with this, you can actually share this model. You can also download it. I mean, you can share this link with any team members and they will be able to play around with this tool. You can also basically download it if you want to 3D print it. So I can download it here, and that export functionality is actually built in. So you can go to OBJ exporter, select your quality. Let's say I want high quality, hit done. And that basically outputs my sketch here. So what I'm going to do is I'm going to drag it into Rhino, import it as an OBJ, and we will basically have a model that we can 3D print and work with, right? So this is basically something that we have developed using Beegraphy on the web, but you can open it in any other software. You can load it into a 3D printer and you can actually get a product made, right? So let's actually do another one. So I'm going to go back here and do another parameter. So let's do one where it's low rotation. Let's have less surface undulation. Number of points could stay as is. I'm going to make 3 lobes this time. Well, actually, let's increase this a bit so that we can see the surface, right? And I'm going to turn this down a bit, scale up, and we can do download and OBJ exporter, done. All right, now that will be the second model. So let's download it as well. Insert file. And there you go. So you can basically work around with this, develop as many models as you want. I hope this was helpful. It's a really exciting product, and I want you to get your hands on this and play around with it. And hopefully you will have a lot of feedback for our developing team, and they will be able to solve all these issues really fast. So go ahead and create your own profile and work with Beegraphy. Thanks for watching.